Ramona. Happy to have everybody with me this afternoon, and happy to have Ramona as my cohort, if we can call her that. I think you are aware that you may not talk. You have access to the chat box. So throughout this presentation, we're going to have a lot of participation. So if you are ready with a pen and a paper and maybe a calculator, although I don't think any of this math is going to require a calculator, we are ready to go. Again, thanks for joining me. I love teaching. I love teaching adults. I love teaching virtually. And probability is one of my favorite topics. So as your screen shows, please put your answer to this question in the chat box. So we have a dial, we have a circle, we have a dial, we have different colors. And this is one of the things that I do in my teaching is I make the students think. This is called the math reasoning test. It's not called the math test, the math reasoning test. So they might look at that and say, wait a minute, there's no numbers. And then if they look at it a little bit longer, they hopefully will say, well, oh, maybe I can still figure this out. So what kind of answers are we seeing in the chat box, Ramona?
We are seeing a lot of 25%, 1/4, 1 in 4, 1 to 4.
That's perfect. And that shows you that there's a different ways of answering probability questions. And the answer definitely is 1/4. And what we can say is that there's 2 white sections out of 8 total sections. And you can say, well, 1/4 of the circle is white, so there's 25%, and on and on and on. Okay, so predicting probability. I'm Jay Willetts from Community College of Baltimore County. I also teach at South Baltimore Learning Center. I have been in the past at BCCC. I usually get too many C's in there, but I only like to teach at places that have a bunch of letters in their names. So what is predicting probability? First of all, let me say that when I began teaching virtually, I soon discovered that I was able to do this well. I enjoyed it, but I was always sort of questioning, are they actually seeing what I want them to see? So one of the first things I did was hook up a second computer, and anytime I go into a class, I go in as myself, and as I go in as an observer. So the bigger desktop computer is letting me see exactly what the students are seeing. So that's a very valuable tool when you're doing virtual teaching. And I always tell my students, I speak 3 languages. I speak English, I speak a little Spanish, and I mostly speak sarcasm. So I love to put little things in like this that sort of makes it fun to be in my class. So everybody help yourself to a donut, okay? I love also to talk about quotes, and I love to show quotes, and the teaching is the profession that creates all other professions. How true is that? And then we often have trouble engaging students in virtual classes, and even to the point of somebody coming up with this cartoon. Don't forget, Mrs. Patterson, I signed up for the do not call on me list. I'm pretending I'm hearing chuckles and laughter. Okay.
Actually, you are hearing chuckles and laughter in the comments.
Okay. All right. So what are the workshop objectives? Well, we have a lot of them. First of all, I want to be able to model effective teaching strategies for various math topics. And today it's probability. And I like to do it with virtual classes and in-session classes. Because, you know, it looks like we're about ready to head back to brick and mortar classrooms. And they may have to do it without me because I so love this virtual teaching. Now, this is probability today, but I want to make sure you understand that the strategies I'm going to show you and the educational resources I'm going to show you, they all can be included in the different topics of probability or different topics of math. Okay, I want to also demonstrate a variety of ways to engage students. I want to be able to enhance class participation, which is sometimes difficult. We have students that are on phones. We have students that are driving along in their cars and trying to be in class. We have students who have babies in the background. You know, it's amazingly complex as to what some of the students are going through with having kids and demands and going to work and all of those kind of things. And another thing that I want to help the students build their self-confidence. And the final objective is to expose viewers to educational resources that show various ways questions may be asked on the math reasoning test. You know, we all teach mean, median, and mode, but do we teach mean by making sure they understand how to find a missing number in a data set when the average is given? Because this is the math reasoning test, and it seems like the questions just go one level beyond what many times they're taught in the classrooms. I also want to provide practice for using the 5 ways that questions may be answered. And you know those as well as I do: multiple choice, drop down menu, which is just another way of multiple choice, fill in the blank, drag and drop, and hotspot. And I'll show some of those as we go through today. All right, predicting probability. All right, now, what is probability defined as? Well, it's the extent to which an event is likely to occur. Notice, likely to occur. And we measure it by the ratio of the favorable options. What option are we looking for to the total number of options possible? Now, we have 2 kinds of probability: independent and dependent. And I'm also going to include, if time allows at the end, I'm going to include some associated activities like numbers of combinations you can have and sequences and things like that. So remember, the probability of something happening tells us only the likelihood of an event occurring. And each event is not affected by other events. And that's what tells us it's independent probability. It's not affected by anything else happening. So we have something like this dial. And I may say, if you spin this dial, what is your chance of getting an 8? And I'm going to just bring that right up because I'm sure everybody has 1 out of 8. But what happens if you complicate this a little bit more by saying, what's the probability of getting a 1, a 2, or a 3? I'll give you a minute to think about that. And let's put our answers as fractions, although we're going to see there's different ways to answer. But if you think about your answer as a fraction, that would be, so we're all on the same page. So what are we seeing, Ramona?
Okay, so we are seeing 3/8.
Okay, and that makes sense because there's 3 different number possibles, 1, 2, or 3. And there's always 8 as my denominator. So that's how many outcomes there are. And favorable outcomes, there's 3 choices.
And we have another answer of 1/8.
Okay. Maybe they were just late in answering the first question. All right. So what's the possibility of getting an even number? Okay. So what's the possibility of getting an even number on this spinner? And by the way, some of you may have questions as we go through. I welcome those questions, but if you would kindly make a list of those questions and ask them more towards the end so we can judge our time better. Because a lot of times I find that questions people ask along the way are often answered as we go develop this whole idea. So if you will hold those, unless Ramona, you can judge whether it's something they need to know before we move on.
Okay.
So what do we got here?
We have 1/2, Pretty much that's the answer that the only
Okay.
answer I'm seeing
Yeah.
is 1/2
Yeah.
or 4 out of 8.
Yeah. Okay. Now that brings up a good point. Is 4 out of 8 correct? Well, it's 4 out of 8 is the same as a half, but like any ratio, any fraction, it has to be simplified. So the true answer would be 1/2. 4 out of 8 would be correct, but it needs to be reduced or simplified. Okay. All right. So what is the probability of flipping a coin and getting a head? Well, obviously, we have one head. That's what we're looking for. And we can either have a head or a tail. I was going to show you my entire arsenal of tools that I teach probability with. I have them in my hot little hands, but I'm not going to risk jumping out of this PowerPoint to show you and getting back in. But just visualize, I have a deck of cards, I have a coin, and I have a set of dice, or more commonly used is just one dice, which is called a die. Okay. Now, what are some of the ways that we can answer probability questions? Well, we can say 1 out of 2. We can say the ratio of 1 to 2. We can say 1/2, which is usually the better, most convenient way to mention it, simply because if you have to use this piece of information to go with other bits of information as we get more complex, then it's probably better said as a fraction. And we can also do it as percent, all meaning the same thing. Okay, so to repeat, probability is the number of favorable outcomes over the total number of possible outcomes. So if you show a picture of this, and I say, what's the probability of getting or choosing a green gumdrop? Well, the answer is obviously 1 out of 3. Now, one of the things that my PowerPoints often or always include are pictures and diagrams. And those of you that are not familiar with where you can find some of these things, and I think most of you are, is you can always go to Google Images and you can type in just about anything you're looking for, however weird it may be. And I just typed in one day, I said, candy demonstrating probability. And there was like 6,482,000 in 0.07 seconds. And you know how that goes. Okay, so this is one of the main tools used in probability. What is the chance of rolling a die and getting a 5? Now, a lot of students don't know what a die is, and that's one of the things in your discussions of probability you want to make sure that they know that's just a single die. And of course, the answer would be 1/6 because there's only 1/6 out of 6 possibilities. And this is sort of repeating what we just did, so I'm just going to go right straight through it. What's the chance of rolling a die and getting a 3 or a 4? Well, it's going to be 2 out of 6, but we would want to reduce that to 1/3. And what's the chance of rolling a die and getting an odd number? Well, there's 3 odd numbers out of 6, so it's going to be 1/2. And notice when you're teaching probability, you're also teaching skills like changing, you're simplifying fractions, you're changing fractions to decimals, to percents. And these basic math operations that we all teach at the beginning of our class are very important. And it's important not only to make sure they understand them, but it's important to see how they're going to use them as they move through the curriculum in order to prepare for this math test. Okay, so I like to pose questions which involve a lot of skills at once. So this question is a probability question, but now it involves geometric figures and things like that. So what's the possibility or the probability of choosing a circle? What is the probability of all these little math manipulatives in a bag? And what's the probability of choosing a circle? Now we're going to go beyond the fact that they can reach in there and play around with these things, and they better be able to decide which ones are triangles and which ones are circles and so on and so forth. But we have this old random thing we have to talk about. So what are you saying?
Okay. So I'm seeing 5/18.
Okay. And that makes sense because there's 5 circles and there's 18 objects. Okay. What's the probability of choosing something green?
I'm seeing 1/3.
Okay. Because there's 6 greens and 18 objects. And I had to laugh. I hope that a lot of you saw Ramona's talk last night or yesterday about some strategies for beginning math teaching, and I enjoyed that. And she did something with colors, and somebody asked her, I believe, what if somebody's colorblind? And I started to write in the chat box that she didn't have to worry because mostly color blindness is red or green. And of course, when I say something like that scientifically, that always leads to discussions, because when I'm in a class, I love to have questions that go into other things, and a lot of times it's science, because I'm a science teacher as well as a math teacher. So, and this leads me into talking about color blindness and what causes it and those kind of things, but that I don't want to get off track at this point, okay? So, I will say one thing though. If red-green color blindness is the same, is this the most common color blindness, and it occurs much greater frequency in males, how did they address that main kind of color blindness with stoplights? How do they know when to stop? See what they say in the chat box. Did I take everybody by surprise?
Position of light.
Yes. The red's always on top, the green's on the bottom. Okay, very good. All right, so what's the probability of choosing a triangle or a rectangle? And that would be 1/2, because if we put them together, we have 9 triangles and rectangles, and we have 18 total. Okay, now, so far we've talked about determining probability. Well, how can you use probability to make informed predictions about other things? Well, what happens, and I always tell my students that the bad news is, guess what? You have math questions on the science and the social studies, and I can visually or auditorily hear them moaning. And I said, well, wait a minute, don't be sad, because these are sometimes the easiest questions. Like, when they show charts and graphs and tables on science and social studies questions, a lot of times it's what would you predict would be an average profit for a company based on what you see so far, and those kind of things. So what are some questions we can ask about probability, which is not just what's the probability of? Okay, so I'm going to flip a coin 80 times. How many heads would you expect to get? And I often, while I'm waiting for you to put your answer there, I often, if I'm doing this in an actual class, of course, I have all my little toolkit there. Usually I have to borrow a coin from somebody because nobody carries coins anymore, but I always have my deck of cards and I always have my dice. I will actually, I won't flip a coin 80 times, but I'll maybe flip it 20 times and I'll say, what would I expect to get? And then I actually do it. And, almost without a doubt, when I flip it, let's say maybe 30 times, I almost always get 15 and 15, or maybe 14 and 16, but it's very close. Okay, what's the answer?
Okay, so most of the answers were 40, and everybody wrote roughly half.
Yes, exactly. So we get 40 because we know the probability of getting a head or a tail on a coin would be 1/2. So we'll do 1/2 of 80. And when I'm doing basic operations, I always say, what's the best way to take half of 80? Well, you just divide 80 by 2. Or what's a third of 60? Divide by 3, and so on and so forth. Okay, if I roll a die 30 times, how many ones would I expect to get?
I'm seeing 5.
Okay, and that's because it's 1/6 of a chance. So 1/6 of 30 is 5. Great. Okay, now hold on to your seats. Put your seatbelts on, because I'm going to show you one of the coolest things I've ever seen. We're always talking about math manipulatives. And I found a great website, and a lot of the websites I'm going to share today you probably already know about, or maybe at one point we get so many websites we forget some of the good ones. Well, this is, and we all talk about math manipulatives. I've heard, I've watched 3 or 4 workshops this week, and I've heard math manipulatives several times. So one of the greatest sites is www.didax.com. Okay, and you're going to get a copy of this presentation. I'm going to get a copy of this PowerPoint, and please note that I accept Cash App, Pay. Oh, I'm sorry, I can't do that, can I? So math manipulatives are, this is some of the ones they've got. They got algebra tiles, they have dice, they have spinners, all kinds of stuff. So if this works the way it's supposed to, we're going to go right to that place. And we're going to look at the spinner. Now you can do all kinds of things. You can create how many sections you want. You can change the colors. You can show with the numbers or without the numbers. And then of course, Ramona, give me a number that you would like to come up with on the dial.
12.
Okay. Okay, now there's not a 12 there, so.
Okay, except I'm seeing nothing on your screen.
Oh, you're saying nothing. Okay. I'm not sure why.
I can see the PowerPoint, but it's blank.
Okay, so it didn't go to that. Okay, well, just pretend that this is a spinner. And I should have got the clue when you said 12, because the highest number is 10.
Okay.
So remind me at the end, we'll go to this site. I'll do it physically and we'll come back to that. Okay.
Okay, so 4.
Well, I'm not going to do it because they
you're not
can't
gonna do
see
it.
it. Yeah.
All
okay.
right.
All right. Now you're back to the PowerPoint, right?
Yes.
And the other one is, and again, we'll do this at the end when I have this pulled up. And please, if you can make a note to remind me to do that, because this is such a great site. And this, the first link took us right to the spinner, and the second link takes us right to dice and numbers, and we can just pull out the dice and we can spin them and do all kinds of stuff. Okay, so that might mean that the rest of this won't show up either, but when I did this, it worked perfectly on mine, but I didn't think it wouldn't be going through to everyone else's. So let's pray that it works now. So another site that is very good is called GEDpracticetest.net. Okay, some of you have heard about this, maybe some of you haven't. GEDpracticetest.net. And this site provides great practice questions with all 4 GED tests, including 2 tests, one with the calculator and one without. Okay, so I'm going to go to this site. I assume you're not seeing the site, right?
That's correct. Not seeing it.
Okay, we'll come back to that one too. All right. So I'm going to go through the, what I was going to show you is this GED practice test. It has so many questions on both the, it has questions on all the practice tests. And what happens is that when you click on a question, you get choices, and you click on the choice, and then it tells you instantly whether you're right or wrong, and why you're right or why you're wrong. And it also has science tests, social studies tests. It has extended response questions, and it's just great. Okay, now here's my little thing. Since I used to be a science teacher, I just thought this was funny, so funny. And this is why science teachers should not be getting playground duty. And you know what? I do this. I put this in class and I say, what does this mean? What does this mean? And you know, I hope nobody wants to know what law that is. Well, wait a minute. You know what it is? Does anyone know what law this exemplifies?
Not seeing any answers.
Okay, I think.
Wait a minute. We have an answer.
Okay.
One is Newton's third with a question mark. Another is second law. Another one is equal and opposite. Another one is kinetic energy.
Yeah. Okay. Well, I think they're all okay. What I remember this saying is that for every action, there's an equal and opposite reaction. So if you let that one kid go, then the one on the end would go flying. Okay. All right. So far, we have discussed independent probability. Remember that probability tells only the likelihood of an event occurring. Each event is not affected by other events. Okay. So the probability of rolling a 5 on a die is 1 out of 6. So how does dependent probability differ? Well, sometimes it's called compound probability. What happens is when two or more related events occur, or they occur at the same time, it is called dependent probability. And if you want to calculate the answers for this type of probability, you determine the probability of each event occurring separately, and then you multiply those chances. For instance, if I said, what's the probability of rolling a 3 and a 4 on a set of dice? Does anybody have, let's see if we have some answers for that. What's the probability of getting a 3 and a 4 at the same time when we roll our dice? And this is dependent probability. One event depends upon the other.
I'm getting 1 over 36.
Perfect. Perfect. We have a smart class today.
Yes, we do.
So what happens is the probability of rolling the 3 is 1 out of 6. The probability of rolling a 4 is 1 out of 6 also. And then the probability of rolling both at the same time, you multiply the individual probabilities. Okay. So back to the old circles again. What's the probability of choosing a triangle and a rectangle at the same time? Now I'm going to put your brains to work. What's the probability of choosing a triangle and a rectangle at the same time?
Uh, 1 over 18.
Is that the pretty common answer?
Yeah, and we did get a 0.
Okay.
And then the question is, did he specify how many draws?
No, it's just all in one draw. I would specify if it was more than one draw. And that comes up later on a different type of dependent probability. So it is 1 out of 18 because we have 1/6 chance of getting the triangle and 1/3 chance of getting the rectangle. So we're going to multiply those and get 1 out of 18. Okay, and we're not going to take the time for this. And what is the probability of choosing a white object and a green object at the same time? Well, that's 2 out of 27 because we have 2/9 of a chance of getting white and 1/3 of a chance of getting green. So we multiply those and we get 2 out of 27. Okay, now let's talk about some teaching strategies. I often include this. I have a whole PowerPoint that's called What Did I Do Wrong? Okay, and what this PowerPoint does is that I pose a question and I give them the answer. And they have to decide, yes, they agree with me and they give me a check. and that's when they can annotate. I'm sure you have your students annotate on your screens. And so they give me a check if it's right, and they give me some kind of a lightning bolt if it's wrong. And I also want to make sure that they are ready to provide the correct answer and be prepared to discuss how they solved it or what I did wrong. This is a type of question that's on the GED test. You've all seen them. They give a question and they say, so-and-so got this answer. At what step did they make a mistake? Okay, so the probability of flipping 2 coins at the same time and getting 1 head and 1 tail, it's 1 out of 4. Agree or disagree?
We're getting some agrees in the chat.
Okay, all right. Because it's a half a chance for each, and you multiply them. Okay, what's the probability of flipping 3 coins and getting 2 tails and 1 head? I say the answer is 3 out of 8.
We are getting some disagree.
Uh-oh, how dare them? But they're right. Because, and so what is the answer? And then they have
Actually,
to follow up.
Now somebody did say disagree. It is 1/8.
Okay, it is correct. It's 1/8. So now you can see how this would be a great thing to use in a classroom. They've got to find the mistake, and they're learning so many different operations here at the same time. And I can do this with probability. I can do it with mean, median, and mode, and I can do it with fractions and all kinds of stuff. And this really, promotes the engagement, promotes the participation, but mostly, and I think everybody is aware, or hopefully will agree with me, that if a student gets the answer correct, that's what I say half of the battle. If they can tell you why that's the answer or explain how it's done, then I'm convinced. That's a great assessment tool. Okay, so the reason why I put 3/8 is I don't know how many students, and you've had them too, that say 1 times 1 times 1 is 3. And in fact, after I go over like exponents laws, and I'll say 2 to the 4th power means 2 times 2 times 2 times 2, and you make them do it visually. I can still, after I spend a whole hour on that, I can say, what is 1 to the 23rd power? And you know they're going to say 23. Tell me I'm lying. Okay, what are some additional strategies to engage students and promote class participation? Okay, here's the problem. I have a choir with 18 male and 24 female singers. It also has 2 conductors and 5 musicians. All matters being considered equal, what is the probability a female singer would be chosen to do the solo? Okay, here's my strategy. I don't want an answer. I want you to analyze this problem for me. And we're not going to take time to do that in the chat box, but some of the things that when I say analyze, people have so much trouble with word problems, and they often say, hey, I know math. I know the math. I just can't do the word problems. And we've all struggled with trying to help students get better at word problems. And one of them is analyze this problem for me. What numbers do you see? Are there any numbers that are not needed? And what kind of question is? I repeatedly tell my students, hey, my goal is to teach you how to do all these operations, but my real goal is when you read the question, if you can instantly say, oh, well, that's a measure of central tendency question, or that's a simplification question, or that's a probability. So if they can identify that, they're on the way to go. Another way I might treat this is I may say, set up this problem for me. a lot of the GED questions don't involve what's the answer. It involves how do you set this up. So so there's two great ways to get the students involved. And in case you're wondering, the answer is 4 out of 7. So it's 24 female singers out of a total of 42, so it'll be 4 out of 7. Okay, what's another strategy? A bakery prides itself on their cupcakes. Unlike Ramona yesterday, everything she talked about was involving food. And I understand how that helps because we're all has a common thing. So a bakery prides itself on their cupcakes. Their routine inventory includes the following ratios. They only have 4 flavors: vanilla, chocolate, cherry, and lemon. And the ratio of each, 30% of the cupcakes they make are vanilla and 40% chocolate, and so on and so forth. So right away, I have put a little bit of a different angle on this because you're used to thinking the ratio is da-da-da-da-da. I'm giving it as a percent. Now, what is my teaching strategy here? Well, let me give you the question first. If a customer randomly chose 2 cupcakes, what is the probability she would get 1 chocolate and 1 cherry together? Okay. So here's my strategy. Teach me how to do this problem. You know, I used to say, show me how. And now I say, teach me how. And they'll start working it. And I'll say, no, you're skipping steps. I don't understand it because you're skipping steps. I have no clue how to do this problem. Teach me how to do it. So that's a great strategy to make sure that they get involved. And this is very difficult because I said, you know, they often can get the right answer, but boy, if they can explain how to do it, and then if they can explain to somebody else, that really lets me know they understand it. And by the way, the answer is 1 out of 25 because the chocolate is 2 out of 5. We're doing this, you know, it's all these percents. We're just I just broke it down to 3 vanilla for every 4 chocolate, for every 1 cherry, for every 2 lemons. So it works out like that. Okay. Now, what is the probability of flipping a coin and getting a head and rolling a die and getting a 4, both at the same time? Well, this is pretty simple, 1 out of 12. And now we're putting different things together, coins with dice and stuff like that. Okay. Here's a different example of dependent probability. Okay, more food, Ramona. Okay, Sam receives a box of cookies with the following kinds: 12 chocolate chip, 10 peanut butter, 8 oatmeal raisin. Okay, so at random, Sam picks a cookie, and it's a peanut butter one, and he eats it. Now he picks another cookie. What is the probability it is a chocolate chip? Okay, so you can see why this is called dependent probability, simply because what happens second is directly related to what happens first. So I'll give you a second. Give me a thought. Give me an answer. So Sam picks a cookie. And it's peanut butter, and he eats it. You have to make sure that you say that he eats it. Okay. You know, when I'm working with cards, I'll have students pick a card at random and say it's a queen of hearts. And I'll say, what's the probability of getting another queen? Or what's the probability of getting another heart? Or what's the probability of getting something else? And you can do so many things. And every time they picked a card and we talked about probability, I always physically let them see me putting that card back in the deck. But then if I want to talk about this, I'll have somebody draw a card and I'll physically make them hold it up in the air. And then I'll say, okay, now somebody else picked a card. And of course, this is where we're talking here. So what do we have some answers here?
Okay, so we have 2 over 15, 12 over 87, And then it looks like it was reduced to 4/29.
Okay.
1/6.
It's 12 out of 29. Okay. Did anybody get 12 out of 29?
I do not see 12 out of 29.
Okay, so what happened?
But somebody apparently did it, but didn't put it in there and said, I got that one right. Wow.
Yeah, that's what my students always say too. Sure. Okay. So this is one of the things that really you have to make them pay attention to it. See, there's 12 chocolate chip cookies left because we didn't pick a chocolate chip cookie first. But now there's only 29 cookies left because we took a peanut butter and ate it. So that's why we get 12 out of 29. Okay. So this is the same type of thing. Jeff has marbles. Tell you how many he's got of each. What's the probability of picking a black one? Well, there's 3 blacks out of total of whatever we got, 13, 14, 15, 16, 17, 18, 24. So it's 8 out of black is 5 out of, what did I say, 24. Okay. All right. So now let's make it dependent now. So he does get a black one and he puts it in his pocket. That's important. He gets a black one on his first draw. In other words, he had a chance of 5 out of 24, and that's what he got. Now he chooses another marble. So what's the probability? It'll be white or blue. Now, using the same idea from last time, okay, what do we have as an answer here?
We have 3/20. I'm sorry, 9/23. 9/23.
Yep, there we go. They got the idea. We can either get 6 or 3, and we took one out. Good. All right. So now here's another teaching strategy. This is going to take a little bit, so I'm going to go through this pretty quickly. A magician is doing magic tricks with math manipulatives. He chooses 3 audience members and has the first one draw a card from a regular deck. My favorite card, Queen of Hearts. The second volunteer flips a coin, and the third volunteer rolls a die. Okay. What's the probability that these 3 events will occur at the same time? You see how these things, and my students will say, Mr. J, you started out so easy, and now it's getting so hard. Yeah, that's how it works. So here's my teaching strategy. Let's work this problem as a team. Okay. Now, if I'm doing like long involved equations and algebra simplification, I'll have one student start the process and I'll say, stop, somebody else take over. And boy, that does make them pay attention. Oh, he might call on me. So, and if I have to make sure they're not on that do not call on me list. But what happens is that we work this together and I'll say, okay, what would be the probability of picking a queen of hearts? And you could do this a lot of ways. You could say just picking a queen or just picking any heart. So somebody will say, okay, well, picking the queen of hearts, that's 1 out of 52. Okay. Now I'll either ask somebody the next question or I'll let them volunteer. And if nobody volunteers, I say, okay, Sam, you gave me 1 out of 52. You pick somebody to do the next part. Okay. And don't, obviously we're going to build a lot of community in our classes so that they feel comfortable around each other and they're not ashamed of making a mistake and so on. So the next person says, oh, that would be, to get ahead would be 1 out of 2. And then the next person to get a 6 would be 1 out of 6. And then I say, well, how do we set this up? This is dependent probability. So what do we do now? And they think about it, talk about it, and they say, okay, we have to multiply those. And then if you've been following it, it's 1 out of 624. So obviously the more events that have to occur, the more unlikely it's going to happen. Okay.
And we did have somebody who put the correct answer in the chat before you gave.
All right, very good. Well, would you send them a chicken box? Because that's what I always tell my students I'm going to do. All right. So, and you can see the amount of time in preparing this kind of a presentation, but you know, it's what we do, it's what we love. So what's the probability of throwing a dart at this board and hitting a white square? Well, with time running, there's 25 squares, and I hope that, you know, we see that we have 5 and 5, so we can quickly count 25, and there's only 6 white squares. Now, what happens if they get a second dart after the first dart is shown, and now they hit a different square? So how would you answer this question? Remember, they throw a second dart, they have to hit a different gray square.
I see 7 over 25.
We already hit that one square, so we only have 6 left. So it would be 6 out of 24 because that one's gone. There's no 25. So it would be reduced to 1/4. Okay. So here's some associated questions. How many different passcodes can be formed from letters A, B, C, and D if each letter is used only once? These are associated type problems. This is how many sequences or combinations. We have a lot. And there's your choices. What do you think would be the answer? If I have to put in a passcode to open this lock, and I can only use these letters once, how would I determine how many different sequences there would be?
Okay, somebody's asking you to clarify the last question.
Which question?
It just says, can you clarify that last question?
You mean to go back to the last one? I really don't want to take the time to do that. I'll be happy to, you know, if they'll send me an email or something, I'll try to clarify it more. But I want to keep moving here so we can get everything done.
Okay, so the answers I'm seeing are 256, 24. I guess it's 4 to the 4th, which is 256. 24, 256.
Okay, the answer is 24. Now, the key here is I can only use the letters once. Once I use an A, you know, I can't use that anymore. Now, if I could have used the letters over and over again, it would have been 256. And notice this is what I call a distractor choice. The GED test does that, and I make sure my students know it. They know the kind of mistakes that people are going to make, and they put them as choices. Okay? So here's a similar question. We have 10 runners that are competing in a marathon. Okay? And ribbons will be rewarded for the first, second, and third place. Okay? So how many sequences of awards will be possible? And due to time, I'm just going to say, wow, 720. Because in first place, we can have 10 people. And then one person will be in first place, so that we only have 9 people for the next one, and so on and so forth. Okay, here's a fun question I often ask. You're given 2 darts to throw at this money wheel. What's the highest amount of money you could win with those 2 darts? That's all. I always add, that's providing you're good enough aim that you can hit the chart. So what would you aim for? What's the highest amount that you could actually win?
I'm seeing $1,000.
That's no fun. Students always say $900, but the answer is 1,000. Because why wouldn't you aim for the 500 both times? Well, that's because, you know, we're adults and we're money conscious. We're going to go for the 500 twice. Okay. All right. So I'm going to go through these. I don't think we're going to be able to go to this. Let me quickly do this. I don't think it's going to be different. So if we do, we're going to pass these and I'll spend the last couple of minutes doing them. So one of my favorite sites is mathantics.com. Okay. And can I assume you're not seeing mathantics.com, Ramona?
That's correct. Not seeing it.
Okay. So I'm just going to go through Mathantics, Aztec Software, Khan Academy, Common Core Sheets. And again, these will be on your PowerPoint. And whenever you get the PowerPoint, you'll be able to see the links. And I'm going to show them to you in a minute. Okay. Math is Fun is a great site for lessons and vocabulary and all kinds of worksheets. Okay. So another place, I love math puzzles. They really make the student think. In fact, sometimes I get students so used to doing puzzles, if I don't do one, if I do a different kind of class opener, I'll say, why don't we get a puzzle today? Okay. A great place to find puzzles and a great place to find all these cartoons that I found is Pinterest.com. And of course, you can always go to Google Images Math Puzzles. Okay. This is one of the puzzles which we're not going to take time to do. If you saw my presentation at Mace or at COABE, I didn't do the same one, but I always use this puzzle because it has a lot of things in it. It has order of operations, and it has algebra concepts and things like that. So I'm going to go through this. Okay, I'm going to send you along with this PowerPoint. I'm going to do an algebra vocabulary word search. I'm going to send you a math problem search. So 6 + 3 = 9. So they have to look through these in order to find the different things. Okay. I'd also like to bring to your attention a Maryland Math Matters. It's an adult education math network. Please, if you'd be interested in registering, send me an email to jwillets@southbaltimoreLearns.org. And I'll put you on the list. And the networking has a variety of things that go to talking about, different things, math. Okay. Another little cartoon I found. I use this in my algebra PowerPoint. Name a book that made you cry. Algebra. And what's the probability there are no more questions and class is over? 100%. And my hobby is wildlife photography. And in a recent trip to Africa, this was my parting shot when I left town. Okay, there's my information, both at CCBC, MD, and my phone number, if you want to copy that down or take a picture of it. And I'm going to quickly go to some of these other sites that I talked. How much time do we have, Ramona? About 4 minutes?
Yes. And so just for those to know, I'm putting in the feedback survey and also the proof of participation link.
Okay, very good.
Go ahead, Jay.
All right. So one of the things that I want you to be able to look at is, and you're seeing the Mathantics now?
Hold on a second. Nope.
No, that's because I quit sharing.
Yes, correct.
Are you seeing it now?
Yes.
Okay, so this is Mathantics. I hope you're all familiar with this. This is a great site. It's run by Ron, and he's an amazing instructor. He has videos about every possible thing. Now, he doesn't get real advanced into, various things beyond algebra and geometry. He does do graphs and slopes and things like that. And he has one on probability, and you can, share the videos online. Just make sure when you're doing your share your screen that you check off, maximize the volume. But I also want to show you that on Mathantics, what happens is that if you become, Mathantics is temporarily free. Well, I want my $10 back. But I don't usually say subscribe to sites that cost, but boy, this one's worth it. It's only $10, but now it's free. So if you subscribe for a whole year for $10, you get access not only to the videos, which you can stop and start and talk and everything, but you get his whole set of worksheets. Okay, and whatever topic you're talking about, probability, he sends you worksheets, all kinds of really neat stuff. So that's one great site. Another site, I got to show you these virtual manipulation things, okay? So this is the didax.com. If we go to the spinner, now Ramona, pick a number.
4.
Okay. Oh my goodness, that's the first that's ever happened. You cheated. Okay. So let me see here. Let me get rid of this. Okay, I'm going to go to this. And here's the one with the dice. And you can drag out the dice, you can do as many as you want, and you can spin them. What's the probability of getting a 5 on 2 rolls? And you drag out a third dice, and it's just 3 dice, and what's the probability I'll get a 2, 2 2s and a 1, and so on and so forth. Okay, then you have the numbers, okay? And you can spin those and do all kinds of neat stuff. So that is a great site to look at, all right? The next one is Aztec. Some of your programs probably purchase Aztec for you. This is a site which it's dollar Department of Labor allows to get proxy hours on it for your virtual classes. And this is such a great site. If you don't use Aztec, and I'm sure a lot of you have other kinds of sites you use which are just as good, but in Aztec they have all levels, foundations and fundamentals, and I always put my students, because they're mostly advanced students, I put them in the bridge class, which is pre-high school equivalency or pre-GED, and then Aztec. And also the Flash is great for giving advanced students a lot of drills to be able to answer questions. So quickly, I wanted to show you that in this one, in the GED, of course, is practice test and all those kinds of things. There's the learning plan. I'm going to go jump to math. And since the topic of the day, the soup du jour is probability, we can find it, do the drills. The drills, these are 10 questions, which they can do. They get instant feedback. You notice this is something similar to what we've already talked about, and they give it in a percent thing. These drills, you get instant feedback, and there's 10 questions, and they can repeat these drills as many times as they want to, and they'll continue to get new questions. What I want to show you here is they have a calculator, which is the Texas Instrument 30XS, and I struggle to make sure and find ways to have students practice with the calculator. And this is the best one I've found, because you can simply, now Texas Instruments will sell you rights to use their calculator for a year, and it's pretty expensive, like $90. And I got it a couple years ago through COABE as a trial, and then it ran out. So, but this right here, you can actually show them how to do fractions, and you can show them how to change fractions. If you do the put in the fraction and you hit enter, it's going to reduce its form, and the toggle switch, change to decimal, all kinds of things. Okay. I think we're out of time. Is that correct? Oh, let me show you this last one. This is the GED practice test.net. The question I had earmarked, you got past the ad. This is a free site. There's 39 questions, and this is, algebra. It's all kinds. These are great tests for them to practice on right before they're ready to take the test. And then you can jump down. I'm going to jump to 19, which is a probability question. And we won't take the time to do that now. But this is great to have, because you can use any kind of test you want, including the extended response. Okay, let me do one more and I'm done. Common Core Sheets is where I get most of my worksheets. And since the soup du jour is probability, I'll click on it. I'll look for some probability worksheets. There we go. There's a probability worksheet. And you can either get it with the answer key or just the worksheet without the answer key. Okay. So when you have that, you can do it with that. And these are very easy to download. I use these on when I'm doing breakout rooms. I use them when I'm doing annotating. I'll put them up on the screen. They have to be in PDF form so you can use them. And the students can annotate on them and all kinds of stuff. So,
you're getting lots of thank yous. And what is the email address that you would like to use for participants to contact you?
J. Willetts, I'll go back to the PowerPoint. It would be the one I'll end up with. This one, okay?
We are seeing a blank screen.
Well, that's not good. Just about the time you think you know what you're doing, you don't. Now you're seeing it.
There you go.
But you know what? What's really good for me is if something doesn't work, I learn how to fix it now. And I shouldn't have said that, because as soon as I do that, I'm not going to be able to fix something. So there's my phone number. There's my email address. If you're going to show interest in the Maryland Math Matters, you can do the same, jwillets@southbaltimoreLearns.org, or you can send it to CCBCMD, and I'll be able to respond to you anyway. All right. I hope everybody has learned a lot of good stuff. I hope you feel more empowered to do what you do. But thanks for what you do. It's not an easy time. I was coming out of Panera Bread the other day, and there was a lady sitting there on a computer, and she says, "Okay, kids, we have 17 more minutes." And I said, "Oh, you're teaching online?" And we had a great discussion, but she does it with high school. I thought, no way I would do this in high school or elementary school. Okay, thank you for your participation, and I'll look forward to hearing from you or getting requests for however I can help you. I do present all kinds of programs to different colleges and different GED sites, so I'll be happy to entertain any requests you may have. Okay, thank you, Ramona, for helping me today. And
thank you, Jay. You are always an incredible wealth of knowledge when it comes to anything math related. So thank you for sharing your expertise and just all your little pearls of wisdom.
All right, thank you.
All right.
Can I leave now?